So today we're going to be looking at finding the surface area of cylinders. Just like with a prism, the surface area of a cylinder is going to be the sum of all the areas of all the surfaces of a figure. In a cylinder, what we're looking at is we have a circular top, a circular bottom, and then we have the side surface, which is what's called the lateral surface of a cylinder. Now this slide's going to show us kind of the formula and stuff like that, just like we did for a prism. This first formula that they show, where its surface area is equal to 2b plus L, is just referring to 2 times the area of the base plus the lateral area. You can definitely use that. I don't use that one a ton, but if it works for you, you can. I tend to encourage students to use this one, which is actually just another form of what we did before, which was where surface area was equal to 2 times the area of the base plus the perimeter, but this time because it's a circle, we're going to do circumference times height. And the reason they're the same is if you think about it, the area of a circle is pi times your radius squared, which is what we see right here. And then circumference is really just the same as 2 pi r. So I know some of you really like to see the more drawn out formulas. You can definitely use this one, or you can use this one, which would be very similar. It's a similar idea to what we did with our surface area of a prism. Here we can also look at, here's a cylinder example with our radius of 5, and then here's our net. So you can use that same idea like we did with the prisms as well, where you can actually draw out the top and the bottom, and then you'll see that lateral surface, which is the side of the cylinder. Here, the distance has to match up with the circumference of the circle, and that's why that lateral surface ends up having an area of the circumference times the height of the cylinder. All right, so let's look at our first example. I would get this down in your notes. We have a cylinder over here that has a radius of 4 inches and a height of 6 inches. We are given the surface area formula. For our assessments, I'll just let you know that I will give you the basic formulas. I won't give you the ones that'll be this detailed, but as long as you know how to apply them. So we're going to look at first, find the area of our two bases. So the area of a circle is pi times our radius, which in this case is 4, squared. So here we're going to use 3.14 for pi, so I have 3.14 times 4 squared, which is 16. And now I'm just going to do 3.14 times 16, which is 50.24. And because we have to take the area of the base and multiply it by 2, I'm going to take 2 times the 50 and 24 hundredths, and I will get 148 hundredths as the area of our two bases. Now I need to find the lateral surface area. So I'm going to find the circumference of the base, which is going to be 2 times 3.14, which is 2 times pi, times our radius, which is 4. And then I'm going to take all of this and also multiply it by our height. So I'm going to go ahead and do this. I have 2 times 4, which is 8. And so 8 times 3.14, which is 25 and 12 hundredths. I'm going to take this and multiply it by 6 for that height, which is 150.72. And now I'm just going to add these two together. Which gives us a surface area of 251.2 inches squared. All right, so I'm going to have you pause the video and I want you to try and work this problem out on your own using that formula that's given for you. So the first thing we're going to look at is our area of our base, just like we did before. That's where I like to start. So I'm going to find the area, which is going to be 3.14 for pi, times our radius, which in this case is 15 squared. 15 squared is 225. And now I'm going to take that times 3.14, and I get 706.5. Now, because there are two circles, I'm going to multiply that by 2 or double it, which gives us 1,413 centimeters squared as the area of our two bases. So I've got that first part of our formula done. So now I'm going to look at finding that lateral surface area again. So I'm going to take 2 times 3.14 times our radius, which is 15. I like to do as much as I can in my head, so I'm going to do 30, because 2 times 15 is 30, times 3.14, which is 94.2. And now I'm going to take that and multiply it by the height of our cylinder, which is 3, which gives us 282.6. And so now that's that part. We're just going to add those two together. So we would get 1,695.6 centimeters squared. So hopefully that's the answer you got when you pause the video. All right, so here's another problem for you. I want to go ahead and pause the video, read through the question, and see if you can reason this one out. So a cylindrical soup can is 7.6 centimeters in diameter and 11.2 centimeters tall. We want to know what is the area of the label that covers the side of the can. So I just like to underline those key parts. So here, if I were to draw out my soup can, I always find it helpful to kind of draw out the models. We know that the diameter is 7.6 and the height is 11.2, and they want to find just the area of the label that covers the side of the can. So in this case, when we're looking at the surface area, we don't care about the top and the bottom. We're just looking for that lateral face. So that lateral face is going to be the circumference of our circle, which is going to be pi, or 3.14, times our diameter, which is 7.6. And then we're going to take that and multiply it by the height of our can, which gives us 1,000. And if we're going to go ahead and round to the nearest hundredth, remember we look at that 7, here we have that 68 or 6, which is going to tell us to round up. So I would say that our rounded value answer should be 267 and 28 hundredths centimeters squared for just the side of the can. All right, one more example for you to try out. Once again, I encourage you to pause the video, see if you can work through this one, and if you have questions, jot them down. You can always send them to me. A cylindrical storage tank that is 6 feet in diameter and 12 feet tall needs to be painted. The paint will cover 100 square feet per gallon. We want to know how many gallons it would take to paint the tank. Since we're talking about painting the tank, we need to know the surface area. So once again, if I start just with that model or that visual. Okay, so when I look here, once again, they're telling us it's the diameter is 12 feet and the height, oops, So the diameter is not 12 feet. The diameter is actually 6 feet, and the height is 12 feet. So if I'm finding the surface area, I'm going to do 2 times 3.14 times our radius. So if our diameter is 6, remember our radius is half of that, or 3. So this will be 3 squared. So here, if I break this down, 3 squared is 9. 9 times 2 is 18. So I'm going to end up with 18 times 3.14 plus our lateral surface area. So our circumference, which is going to be pi times diameter, or 6 times 3.14 times the height, which is 12. Once again, if I do the mental multiplication, I can do 6 times 12, which gives me 72, times 3.14. So 18 times 3.14 is 56.52. And 72 times 3.14 is 226 and 800ths. So now if we add those all together,